Well, let's make a start with the theorem of Pythagoras. We did that, of course, in an earlier program, in fact in program 1, where we've got a right angle triangle and we know the hypotenuse, and we know that if we square the two other sides, add them up, then we get the square of the hypotenuse. Let's revise that. So here we've got the right angle triangle, we've got the hypotenuse there being the longest side, always opposite the right angle. And indeed that's where it says if we square the two sides there, AC and BA, we add up the squares, we get the square on the hypotenuse, BC squared. Sometimes that's written as A squared equals B squared plus C squared, because we call that side A, little a, because it's opposite angle big A. Let's go straight into a problem. Here we need to find the length of the hypotenuse. See, the two sides are given, 3 and 5, but we have to find the hypotenuse. So we square 3 and we square 5, add those up, 9 and 25 makes 34. Then to get the value of the hypotenuse, we have to take the square root out of 34 and round that to 2 decimal places. 5.83, correct units, centimeters. The next problem, a little bit more difficult. Here we actually know that the hypotenuse is 5.2 kilometers. The other side is 2.4. We have to find the third. This is actually a matter of subtraction. We actually subtract 2.4 squared from 5.2 squared. I've written that in this particular format with brackets and the square root sign. In the calculator I get 4.613. Now I've actually given it to 3 decimal places because the answer is in kilometers and we were asked to give it to the nearest meter, and of course there are 1,000 meters in 1 kilometer. Now these problems can become quite difficult. In trigonometry you have to have a good knowledge of Pythagoras, so let's do one more problem on Pythagoras, a little bit more difficult. In this particular problem, we are given that AB equals BC, so those two sides are the same. This particular hypotenuse in the small triangle is 5, while the hypotenuse in the big triangle ADC is 8 meters. Now, let's first of all call AB x, and then we can get from Pythagoras that dA squared should be the square of 5 minus x squared. In other words, also, of course, dA squared in the big triangle becomes 8 squared, subtract 2x, all squared. And here's where your knowledge of algebra becomes important, because you should know that 2x all squared is actually equal to 4x squared. So I've got the same thing as I had on the previous graphic, and we equate, because both these expressions are equal to dA squared. So I get 25 minus x squared equals 64 minus 2x all squared, which is 4x squared. Then you solve this, it's an equation, and we get 3x squared to be 39, x squared to be equal to 13, and from that we should get finally that dA then becomes 25, see that's the 5 squared minus the x squared, which we found to be 13, so it's 25 minus 13, and that becomes 3.5 meters, which you may want to check on your calculator.